Okay, we're going to start 3.7, which is all about rational inequalities. And before we jump into the rational ones, let's just do one problem which can remind us how to do the polynomial inequalities. So just a reminder, because the method actually of doing rational inequalities versus polynomial inequalities is very, very similar. So let's say you have x minus 1 times x plus 2 squared. We want to solve for what values of x is that greater than or equal to 0. Well, what do? You find where this thing equals 0, where the polynomial equals 0, and then you divide up the real line over there. So for example, here x equals 1 and x equals minus 2. Those are the values where this thing actually equals 0. And all we do now is plug in one number in each subinterval. So for example, here we could plug in -3, maybe 0 and 2. And what do we plug this into? We plug it into the polynomial x minus 1 times x plus 2 squared. So for example, if we plugged in -3, we would get a negative times something squared. So overall, you get a negative here. The polynomial is negative. If you plug in 0, you get a negative times, again, a positive. So you'd get overall a negative here. If you plug in oops, not 2 here. Yeah, 2 is fine, sorry, whatever. 3 is okay as well. If you plug in 3, you get a positive times a positive, so you get a positive number overall. So again, these are referring to the sign of p of -3, 0, and 3 respectively. So that's maybe bad notation. Let me just rewrite that. So we're taking here, this is the sign of p of -3. This is the sign of p of 0. And that's the sign of p of 3. And what are we looking for? We're looking for when this thing is greater than or equal to 0. And that occurs right in this area, right here. So hence our solution is this occurs when x is at least 1. Right? Because we got the positive region in that interval. So our solution then is 1 to positive infinity. Okay? So this is the method for solving inequalities for polynomials, and it's essentially the same for rational equations. So let's just do one example of a rational inequality. Well, let's take x minus 1 divided by -2x plus 1 times x minus 4. And I'm going to do examples where everything is already factored. So in this video, everything is going to be factored. In the next video, we'll do one or two where we have to factor. So our first job actually is always to factor. So first thing we always do is factor the numerator and denominator. And again, here I'm giving ones that are already factored. So here we have already factored. And the second step is to see where is the numerator equal to 0, and separately, where does the denominator equal 0. So for example, in this case, numerator being 0, well, when does that occur? That occurs at x equals 1. The denominator being 0, when does that occur? That occurs at -1/2 as well as 4, if you solve for the denominator being 0. And those are your dividing points for, you do the same procedure now. You draw a real line, and you break up into subintervals by these points. So here's -1/2, here's 1, here's 4. And so we want to plug in one value in each subinterval. You just collect all of these values together. So here, say we plug in -1, plug in 0, 2, and 5. And we say, okay, overall, what do we want? We want this thing to be less than 0. So we're looking for the negative sign, strictly. So what are we plugging into? Let me just rewrite the polynomial here. We have x minus 1 over negative 2x plus 1 times x minus 4. This is what we're going to be plugging in the value of x equal -1, 0, 2, and 5 into. So when we plug in, we get p of -1. Well, we get a negative overall on the top. Let me do a little computation for these off to the side. So p of -1, that's -2 divided by -1, and then -5. We have overall 1, 2, 3, 4 negatives. That's a positive. Okay. P of 0, we get -1 on the top divided by a negative, and then 1, and then -4. So we have 3 negatives overall. That's a negative. P of 2, we get a +1 over a negative. 2 times 2, 4, plus 1, 5. 5 minus 4 is 1. We have a single negative overall. That's going to be a negative, right? I'm sorry, no, that's not correct. It's going to be positive because this number is not 1. This number is 2 minus 4, which is -2. So we're going to have 2 negatives. It's a positive. And finally here, when we plug in 5, we're going to get 4 on the top, and then a negative 11, and then a 1 here. So overall, we have a negative sign. So what do we want? We want this thing to be less than 0. Okay, we want p of x to be less than 0. And that occurs right here as well as here. So between, so our solution then is x has to be between -1/2 and 1, or x has to be bigger than 4. So in interval notation, our solution is open interval -1/2 to 1, as well as everything beyond 4 strictly. So this is our solution. So again, what does it say? Whenever x is here and somewhere either between -1/2 and 1 or beyond 4, then the polynomial x minus 1 -2x plus 1 times x minus 4, this is less than 0. Okay, that's what this whole thing is saying. Okay, let me leave you here with an exercise. So try 2x plus 3 squared divided by -x plus 2, x minus 5. And we want this thing to be greater than or equal to 0. So it's already factored. All you want to do is find where the numerator is 0, then where the denominator is 0, and then break up your real line into subintervals and plug in numbers in between in each part. Okay, and that'll determine the solution. Okay, we'll start with that in the next video.